Hello, today we're going to talk about empirical rule and how to understand it, and later you'll learn to apply it to your lab and other examples. So what is empirical rule? Empirical rule combines mean, standard deviation, and the shape. And the one very important rule. Now, what is mean? Mean is just the average of a data set. Standard deviation describes the spread, and in normal terms, standard deviation is like an average distance between the mean and any given data value in a data set. So it's like an average distance between your numbers and its center. Shape. Shape is just what the distribution looks like. Empirical rule applies to a very specific shape. It has to be a bell-shaped. And then mean and standard deviation are just calculations that belong to your data set. So let's say, for the sake of the example, that I have a class of students, and the average height of students in my class is about 66 inches. Standard deviation is about 2 inches. And heights do make up approximately bell-shaped distribution. What does it mean? That means if I draw a bell-shaped curve, the center of this bell-shaped curve would be my average, which is 66 inches. That's your mean. This right here represents the heights in inches. And the standard deviation from here will change 2 units left and right about 3 times. So you will have plus 2, it's going to get us to 68, plus 2 is going to get us to 70, and plus 2 is going to get us to 72. Then if I go to the left, it would be minus 2, so that's going to get us to 64. Minus 2 again, going to get us to 62, and minus 2 again, going to get us to 60. So I have this distribution. Empirical rule says that if you have a bell-shaped curve like this with specific average and standard deviation, then within one standard deviation, make it a different color here, interval within one standard deviation of the mean, which would be this right here, will contain 68% of all the heights and students in the class. Approximately 68% of all the heights and students in the class. If I go 2 standard deviations out, meaning now I'm going to be between 62 and 70, inside of that interval, that's going to get me to 95% approximately of all the heights. So all the students between the heights 62 and 70 will make up 95%, so it would be all of this, 95% of all of the data set. And if you go 3 standard deviations, which would be from 60 to 72, that's going to be approximately 99.7% of all the data covered between 60 and 72, which is almost the entire data set, but not exactly entire data set, because you still have some area that's not covered here and some area that's not covered here. It's not a lot. It's about a 0.3%, because the entire curve represents 100%. So, how to understand this? Well, most of the people would fall within the 95% curve, within the 95% interval. And this would be your kind of a usual variability of heights. Anything outside of that, which would be this part right here and this part right here, will contain another 5%. Why? Because this is 95. So in the middle, so that means on this side you'll have about 2.5% left, and on this side you'll have about 2.5% left. 2.5% or 5% total is not such a big likelihood, which means yes, you could have people that are taller than 70 inches and shorter than 62 inches, but there's only 5% chance that they're going to fall above 70 or below 62, which makes it unusually small percentage of people. So anything outside of 70 or 62, I would say up to the third standard deviation, would be considered unusual. So this right here is unusual, and this right here is unusual. What about outside of 72 and outside of 60? Now, if we know that between 60 and 72 we cover almost 99.7%, that means we have 0.3% left below 60 and above 72. So this shaded area is really small. You can still find people that are taller than 72 inches. You can still find students that are less than 70 inches in height. But according to my information, that's going to be very unlikely. Only 0.3% of the population will be in those shaded areas. So that means, because it's so unlikely, the people with those heights would be considered, according to my data, extremes here, or outliers. Outliers and extremes. And that's how you should understand empirical rule. You need to know these percentages, and you need to know what's usual percentage, 95%, 68%, what's unusual percentage, it's outside of 2 standard deviations, up to 3, and what's outliers and extremes. Those are the values that hide in the very tails of this distribution, outside of 3 standard deviations.